So, in this video, we are going to talk about the two kinds of interest rates. They are nominal and effective. Okay? And the two things you're going to want to look out for are the following. So, whenever we talk about nominal interest rates, it always goes or comes with how often you compound it. All right? In other words, the frequency of compounding. So that's one thing. And the other thing is when you want to compute the effective interest rate, you have to know the nominal one first. All right? So the effective rate is actually derived from the nominal interest rate. And you'll see all that. But just look out for those two things. Okay, so let's go to an example. Let's remember this formula first. This formula gives you how much money you're going to have at the end of year t. Okay, that's this function b of t in blue. If you deposit some money, P, into a bank that has some interest rate R, and they compound that interest rate, let's say, n times a year. All right? So if you have, for example, an interest rate of 7%, and it's being compounded biannually. That is horrible. All right, so biannual. There we go. Then let's also say that you invest $500 in this bank. So that is your initial deposit. And the question is, how much money do you have by the end of the first year? So how much by the end of year 1? Question mark. Now, according to this formula, all we're going to have to do is take t equals 1 and simply plug it inside that function b. Okay? And according to the formula, when you plug that in, and we put in all our other stuff, of course, so the initial deposit is P, you get 1 plus, well, the interest rate is 7%, so we plug in 0.07. Then you divide by the number 2. And you raise all of that to the power 2, and you multiply that exponent by 1, because that's what t is equal to. All right, you plug all of that into your calculator, and actually what you get is 500 times 1225. If you plug that into your calculator, you get $535.61. I've already done all the computations, but you should check this with your calculator. Okay, so that's how much money you have by the end of year 1. Not a big deal. But I want you to look at this part again. Okay? I am going to rewrite that in a different way, and you can probably guess how I'm going to write it. Okay. Just like that, to the 1 power. Now look at that, and look at the formula on the top half of the page. Okay? Compare those two, and it says that $535.61, you can get it by depositing $500 and compounding at the interest rate, use the interest rate 7.1225% and compound it just once. Okay? So it turns out that that number there, that interest rate you get, is the effective one. That's the effective interest rate. In other words, in this, for example, it's 7.1225%. And so what is the effective interest rate? It's simply the rate that you would compound your deposit in if you compounded it all at the end of the year 1 time. Okay? As compared to the nominal interest rate, which could be compounded more than once a year. For example, in this example, it was compounded twice. Okay, so let's do another example, see you can get the idea a little better. Okay, So let's say that you have the bank compounds continuously this time. Then instead of all that fancy stuff in the parentheses, all right, you simply have E. So let's again deal with a 7% interest rate, but this time it's going to be compounded continuously. Okay? And again, you can start out with $500. That's fine. Actually, doesn't matter what you start out with because I'm only going to ask that to find the effective interest rate. So the question is, what is the effective interest rate? Question: what is the effective rate? Question mark. Okay. According to the last example, all we're going to have to do is use this formula for B. This time, this is the one for continuous, if something's getting compounded continuously, and plug in t equals 1. So this is equal to 500, then e to the power 0.07, that's the interest rate, and you multiply by the number 1 because that's how much time you want to wait. Turns out that that's equal to, there we go. Computer's thinking, here we go, is equal to 500 and then times 1.07251. All right, so it's kind of similar to what we had before, but you can see the numbers actually different. And of course, it's because we're compounding continuously as opposed to biannually. But anyway, what's the effective interest rate? Well, you look at that number and you just take the decimal part of it. So it's 7.251%. Okay, that is the effective rate. All right, so it's pretty easy. And again, what is the effective rate? It's simply the rate that the interest rate you would get if you compounded everything just once at the end of the year. Okay, so that's again the difference between the effective rate and the nominal rate. The nominal rate always comes with how often you compound it, while the effective rate, it's understood that you only compound it once a year. Okay, and that's how you get that the numbers have to be different, unless of course the nominal rate happened to be compounded once a year, in which case it's exactly the same as the effective rate. Okay, and that's it.